the chassis looks today. That was something we used to manage as IT engineers, fresh out of college. We used to manage this into the data center, wearing a thick jacket, walking into the data center and just, with our toolbox, maintaining them. We don't do this these days. So whatever we do is on a very high level abstraction on top of that. What happened yesterday? Don't take me literally. It's not yesterday, but yes, a few years back, is that servers were replaced, and people like us, we started managing virtual machines. Virtual machines are again, so nothing changed from managing the operating system. So you still manage an operating system like Linux, Windows, or Solaris, AIX, even mainframe. So you still manage an operating system. You should know how the operating system works, and you still go into the operating system and then do your job. But what happened was you lost access to the data center. You still had few people in the data center who used to work for you, who you can give a call and say that, why don't you reboot this big box for me, because my VMs are not there. My VMs are not moving from one box to another. So that's where we transitioned into virtual machines. So virtual machines were, in that physical box, we could actually put in 4 or 5 virtual machines in. And the virtual machines started sharing compute resource, storage resource, and memory resource, right? So that was a cost benefit for the organization who were adopting virtual machines. And I'm talking about 2007, 2008, 2009, when virtual machine became a thing. And they started lifting and shifting workloads from physical servers into virtual machines. It helped was, the initial benefit was cost, because instead of having 20 servers doing 20 different things, you can have one server in which you can run almost about 4 virtual machines. So they got a cost benefit straight out of it, right? Now, what we could do is you could make 4 VMs doing the same job. So if it's running an application, make all of them run the same application and create what we call high availability. Now, high availability is a desired state in the industry today, where you want to run your service, whether that's your website or a mobile app. You want to run it all the time without any downtime. That's a high availability principle, which all of us tries to achieve these days, right? So the virtual machine thing was still yesterday. Now what we have is containers, and that's the topic of the day. So we're going to talk about containers. I'm going to come back to this pretty picture on your screen. It won't make any sense until we really come back to it. So this is the agenda for the day. Quick thing is that I do have a small demonstration like our previous presenter, and it will be on containers. Containers, so we'll start with the container vernaculars. So there are a few jargons, few vocabularies which we will use today, and these jargons are based on what we use in the industry today. Then we move on to understanding what are containers. Then we talk about 12-factor app designing and cloud native design. The previous presenter presented on data, and now we are more on application side of things. So data is where you store your data. Application is what consumes the data. So we'll talk about more on app and app building principles. We'll also talk about why to use containers, what's wrong with VM, why can't we run in VM. We will visit that aspect. And then the next section where we talk about the container concepts gets interesting, because that's live demo for you. So we will see what images are, what are container registries, what is an image build process. Then we will introduce to a new world, and this is what I do today, is Kubernetes. So Kubernetes is a container orchestration platform where you're not running one container, but you're managing tens and thousands and millions of containers all over a cluster, what we call a Kubernetes cluster. Finally, we will discuss some next steps and options for most of you. If you want to pursue this line of study, or this from an academics perspective, or from a perspective where you want to actually invest your time in the container world or in the cloud native world, which is very dynamic and it's changing every day, and it's more about learning new things every day. So we'll end with that and take some questions at the end of that. Okay. Okay, so to move on, so I talked about some container jargons or container vocabularies, or some languages which we use. So containers are used to encapsulate a service or an app to do just that specific functionality. I'll come back to what containers are. So just let's go through these vocabularies first, and then we'll come back to a microservice. A microservice is a service designed to do a single task. So you might say that, hey, the container is also doing one service and microservice is also doing one service. Yes, that's correct, because containers are supposed to host a microservice. Then we come to cloud native design, and cloud native design, we talk about cloud these days every day. So this is in the cloud, that is in the cloud. What is the cloud? I think now, as the industry stands, cloud, there have been 3 major cloud providers, and there are a few others as well. So Microsoft, Google, and Amazon. Amazon being the pioneer of cloud, has taken everybody ahead. So they are way ahead in terms of their footprint in the cloud world. However, there is a debate happening in the industry that which cloud do we choose? Do we choose one, or do we choose 2? Or do we choose all the 3 and coexist in all of them? So, and that's from a large enterprise perspective. All the big enterprises are having this debate that do you want to exist on one cloud, 2 clouds, or do you want 3 clouds? Then if we do choose all the 3 clouds, what's the benefit of it? And will our applications and databases work on all the 3 clouds? So that's the thing. So cloud native design is a principle or a practice which we do these days, where you develop your apps and databases and peripheral services like your brokers and MQs and everything based on certain principles and guidelines, which will allow you to retrofit your application in any cloud, right? So we'll take a look on those principles. What are those principles, right? Pets. So I'll use this term a lot in the presentation, pets and cattle. So when you say pets are like, you have a dog, that's your pet. You have a cat, that's your pet. Some people like pet, some people do not like pet. And that's what pet is. And in the cloud world, pets is almost the same thing. So in the cloud world, pet is something which you cannot lose, because the person who has a pet will always love a pet, right? They cannot harm their pet. They cannot destroy their pet or hit their pet. That is why something which you protect. Just like a child, you protect your pet as well. So in the cloud world, when we say pet, is something which you cannot remove or destroy or kill or something like that, right? So that's a pet. What's a cattle? A cattle is something which we eat. I know there are some vegetarians maybe on this line. They do not like killing meat or having meat, but that is the fact in the world. That is the food chain. You will have cattle. Cattle are for giving you food supplies. And in the cloud world, cattle are something which can easily be replaced. So I will use this word pet and cattle. Cattle can be easily replaced. Pets cannot be replaced. So, and we will use these terms inside the presentation. Now, coming to the big question of the day. So what are containers? Containers, as I said, is a new concept where you're actually, so I talked about virtualization before. So you have virtual machines which have unique operating system. That means you will install an operating system on a virtual machine. That can be a Linux operating system, that can be a Windows operating system, that can be any other operating system which is derived from a Unix-based system or a Unix-based system, right? Containers are, at the moment, Windows still support containers, but it used to be a Linux thing only because it came out with a certain version of Linux kernel. Linux is derived from Unix. Most of you in your subject matter, you must have gone through Unix and C because they are all derived from the same person who wrote the book Let Us See, right? So Unix is where everything comes from. Even Windows is a derivation of what we have today as a Unix derivation. So containers actually came in a certain version of Linux. Containers came as LXCs, and which is known as liblxc in the diagram. So that is a feature of the kernel which allowed you to do 2 things. So kernel is an operating system has two modes, a kernel mode and a user mode. In the kernel mode is responsible for taking the signals back to the hardware devices. So whether it's your CPU, whether it's the motherboard, so whatever message you want to pass on to the hardware device, that's where the kernel comes into play. The user mode is where you run your applications on. In the user mode, whatever instructions you pass on back to the kernel will translate that into a language which the hardware will understand and pass it back to the hardware so that they can execute that for you, right? So in a version of Linux, they introduced libLXCs, and libLXCs was Linux containers. So what they did was they said, now I'm allowing you to virtualize the kernel itself. So previously, when we used to have virtual machine, we used to put in distinct operating system, which is a distinct kernel on top of a physical hardware to make them virtual. So all we were doing is that I have 4 operating system. It will run on this physical hardware, but they will all have 4 distinct kernel. When it comes to containers, the kernel, the operating system kernel, is shared among all containers. So there's a common kernel. Now you're virtualizing that using container technology, which is C groups namespace virtualization. So the Linux version, the kernel version allowed us to virtualize the namespace and C groups, and then finally apply virtualization at the kernel level. Now, then what happened? Then there was a company called Docker. They released a management system for this. Now, containers have existed for a long time. It's just that it was a feature in the kernel level. People who used to do operating system programming, they were already aware of it, but nobody was using it. Nobody was using the advantages of kernel virtualization until 2000, when container 2002, I guess, when Docker came out, said that, okay, now I'm going to release a software or version of a tool which will allow you to manage kernel virtualization, right? So you did not have the mechanism to do kernel virtualization easily. All you're now doing is you're allowing Docker to release a tool which can actually, with a few set of commands, you're allowed to do kernel virtualization. So that's where containers came into play. And all you're doing is you're virtualizing your kernel into multiple namespaces, and they are providing you an isolation at an operating system level, right? So that's what containers are. If you see, I'm sure most of you are familiar with it, and if you're not, I'll tell you how you can get. So if most of you have been to Task Manager, if you're using Windows, you have seen Task Manager. Task Manager is a place where you can see all your processes. You right click on your taskbar, you open a Task Manager, you can see all your processes, right? A container is a process running on an operating system. That's how simple it is. It's still a process running on your operating system. However, the only difference is that process has its own namespace boundaries. That means that process does not know that your machine may have a C drive, may have a D drive, may not have a C drive or a D drive. It doesn't know anything about your machine or your operating system. So that's an isolation which the container provides you, right? So it's a namespace isolation. It does a network level isolation. It does a process level isolation. It does an IPC level isolation. IPC is inter-process communication level isolation, right? So that's what containers offers you, an isolation. Let's move on to the next slide. I will come back to containers again, but let's talk about the trends in the industry. So there's a link here, which is called 12-factor app design. I'm going to just tell you that there is a thing called 12-factor app design. Now you can actually go to this link and find all about it. I'll just open this for you and I'll show you. And maybe in your leisure time, you would be able to go through all of this. These are the modern way of designing apps. One is, how do you manage your code base? How do you manage your dependencies? How do you manage your configurations? How do you manage your backing services? How do you build your app? How do you release it? How do you run it? What is the process level segregation for your app? what is being stateless? Port binding, concurrency, disposability, dev and prod parity, and logs and admin processes. These are certain guidelines of developing an app today. This is known as the 12-factor app development. Now, why would you use something like 12-factor app development? That is because you want your applications to be as fluid as possible so that you can coexist in all three clouds, all three public cloud. You can migrate from one public cloud to the other public cloud, or maybe you are running it on your own laptop or your own data center and you can easily move to cloud. So that's being cloud native. So when we say cloud native, everybody talks about clouds today, but the problem is there are stiff competition between all the three clouds, and it might happen that one of them will back out in future. So all you need to do is you need to be cloud native when you're building your app. So how do you become cloud native? First principle, again, this is again coming from sources from all three clouds agreed on this. So AWS, the big pioneers, AWS has agreed on it, Google has agreed on it, and so has Azure has agreed on it. So if they have agreed on it, there is a principle they are agreeing on to, which is design for automation. So whatever you do today, to make it very simple, if you are doing something today on your machine, on your laptop, make sure you're not doing that tomorrow again. If you have a task which can be automated with some form of code, configuration, or with some form of automation, please do it. That's designed for automation. If you are doing one thing 10 times, that's a case for automation. Whether that's building a server, whether that's installing a software on top of that server, whether that's deploying your app, whether that is daily routine where you restart the app because the app falters at some time in the middle of the night, all of that is a case of automation. If you are repeating one activity for the 10th consecutive time, you have to automate that. The second principle of being cloud native is how do you handle state? Now, this is a very vast topic and I'm not going to spend much time on it. So think about state in this way. So when you're logging into something like your Gmail account or any email account provided by one of the service provider, I will use Gmail as an example because most of you are logged in into meet.google.com and I know most of you have a Gmail account, right? So if you're logging into a Gmail account and you open another tab in your browser and you try to log into Gmail again, does it ask you for an ID and a password? No, it doesn't, because it's maintaining a state and it knows that you are the right person for that, right? So it's maintaining a state somewhere, it identifies you, and identification is not the only step. It also maintains that state in your machine, and that's called maintaining a state. So when you're thinking about the principle 2 of designing a cloud native application, you have to handle state very cautiously, because each and every cloud provider, let's say tomorrow I'm going to move a big application like YouTube. You know how big YouTube is today? So YouTube, so the previous presenter talked about trillions of data. So YouTube is now today 30 million terabytes in just one location. That's just one location, 30 million terabytes. And why is that? Because you are allowing a platform where content is generated by end users. I will compare that with another platform, which is Netflix, which is again a very cloud native application that doesn't have that much volume when it comes to data. Now, coming from the old concepts where YouTube is that big, let's say I am running YouTube. Hypothetically, YouTube is definitely running in Google because it's part of Google, but hypothetically, let's say I want to migrate something like YouTube into Amazon or AWS. It's going to be difficult, because how are you going to manage the state of it? There will be logged in users. You cannot do downtimes. You cannot do downtimes with applications like YouTube and Gmail. People will start complaining. So you still have to do a live migration, but you still have to maintain the state somewhere. So you have to be very smart about maintaining a state in the cloud world. The next thing is favoring the native services. So when we talk about native services, I think Madam Anvesha showed few services in cloud. I think she showed ADF, which is Azure Data Factory in Azure. She also showed about Azure Synaptic Analysis. These are cloud services. She also talked about PaaS. She also talked about IaaS. These are all PaaS services, right? So Azure Data Factory, from a cloud provider perspective, that's a PaaS. Why is it a PaaS? Because it's giving you a platform. You're not managing the infrastructure. So it's not an IaaS. So it's a service. It's a PaaS service. Now, it's a native service. Why? What is a native and a non-native service in the cloud? So if Anvesha did not use ADF, and let's say took one of the data warehousing product, sorry, it did not use Azure Synaptic Analysis and took one of the data warehousing products from the industry, like let's say Teradata. She picks Teradata and she puts it on the cloud. That's not a native service for the cloud. Microsoft is not offering you Teradata as data warehouse. The native service for data warehouse in Azure is Azure Synaptic Service, right? So always favor the native service. And you have to build. So it's not always possible to favor for native services, right? So let's say you're migrating from a cloud A to cloud B. You cannot always favor the native service. Cloud A, so one good example would be functions. So function as a service is a service which clouds provide. AWS provides Lambda, whereas Google provides Google functions, cloud functions, and Azure provides Azure cloud functions. Completely different architecture, completely different. How can I, favor the native service? Then the migration becomes difficult, right? But the principle is, if you are doing the first and the second principle correctly, that is, if you are designing for automation, if you are being smart with your state, it will be you can still use the native service of Amazon and still move to Google without any problems, right? So that's what favoring native services is. Practice defense in depth. Everybody talked about security. Security is of utmost important, and it used to be a hot debate in every forum we used to be in, where if I am going to move to cloud, the first thing they would ask, it's not secure. How can you secure cloud? So practice defense in depth is a cloud native principle which allows you to be independent of the cloud security. Cloud today is much secure than it was 5 years back or 6 years back, right? So they will keep on adding security features, and hackers and people who does wrong things on the cloud will also find new ways of penetrating it, right? So there will be security updates happening in cloud. There will be intelligent people doing bad things. So this is not going to change in this world. But what you need to do is probably make your piece as secure as possible. And there are a lot of techniques to do that. You have to adopt to a policy. I'm going to do deny by default. I'm going to just allow what is actually needed, explicit allowance, multi-factor authentication. All of these are defense in depth principle of the cloud, right? So these are a few things which you need to adopt if you want to build a cloud native application. Another thing is, everybody in the cloud world, whether you are a developer, whether you are an engineer, whether you are a site reliability engineer, whether you are maintaining containers, whether you are a tester, always wear an architecting hat. So always do not ever stop being an architect. Whenever you're deploying something on the cloud, think as an architecture perspective, think from a flow perspective, how your flows are working, and think from an end-to-end perspective. That's how we become a cloud native app. Development should start on cloud. So enough about that. Now let's come back to containers. So the reason I spoke about cloud native is because the technology itself was meant to be cloud native. So if you are putting your app on something like container, so you are developing your app on containers, you're actually adopting a cloud native principle. You're forced to adopt certain cloud native principles, right? So one is, containers overhead is very less. Its cost is less because you only think about one service and the cost goes down drastically. So you are not thinking about big services. You're thinking about microservices. One of the good examples would be I think, and this is again a real life example. If you ever been to a shopping site like Amazon or Flipkart or all of these shopping sites where you go and order stuff, you might think that it's just a website running in one server. No, it's not. It's probably thousands of containers which is running there. And when we say containers, what does one container run? You might ask that question, that one container of Flipkart, what is it running? And the answer would be maybe just shopping cart. That's it. So when you click, when you find an item in the web page of Flipkart and you click onto it, and that functionality after that click happens on that item, and still that time it gets added to a shopping cart, could be one microservice. That's it. That's all one microservice. That similarly in the other sections of Flipkart where you go to checkout and you put in your debit card details, or you say cash on delivery, that could be a payment microservice. So to make a complete website or a complete web application like Flipkart, you can have more than 100 microservices talking to each other. And each microservice, as a principle, as a container principle, should run in one container. That's the principle. You might even deviate from that principle because you might have a reasoning behind that. That's totally possible, and we have seen those use cases. The next thing about containers is that how portable it has to be. And the portability of container is one of the reasons why we say it is a very cloud native technology. You build a container, and I'll show this during our demo. You build a container, that means you are actually building one small microservice inside a container. You package it and you put it in a thing called a registry, a container registry where all your containers will stay. Now, no matter where you are deploying that container, it will do exactly the same thing with the exact same behavior. Doesn't matter which environment your container is getting deployed. A shopping cart from Flipkart will be a shopping cart in Amazon if you deploy it, in Google if you deploy it, or if you deploy it in Azure as well. So that's the portability concept of a container. Consistency, this is again a practice which is, I will debate on this. I have put this slide in, but I'll still debate. Consistency still depends on the development practices. So consistency is about how consistently you are actually growing your code base, or how consistently you are actually delivering your product. That still somewhat depends on the developers, not on the container technology. It can't make you consistent because you are the person who are coding it. But still, at some point, containers bring some consistency because of its portability, it brings some consistency. Speed of deployment is another reason why we adopt container technology. One quick example would be, and this is a real life example from my job. I think 2 to 3 years back, if we started a new project, and this is a banking project where we were trying to do a fraud analysis, all that application would have done is that application would have got some data from some sources and would analyze based on some models and rules written that whether that's a fraud or potential fraud or not a fraud. That's all that application did, right? And we started this project in 2011. We called it Credit Risk and Fraud, so CRF. And at that point of time, what happened was that when I was engaged in that project, I told that, hey, for me to build all the servers, I will at least take 40 days because I have to procure the server, I have to put it in the data center, then my data center engineer is going to go in, he's going to rack and stack that, cable that, all of that will be 40 days. Application team said, okay, then after you give me the servers, and that's again the development servers, it will take another 3 months for me to do at least the first module. Okay, and then finally what happened, the project timeline became 2 years to deliver a project like just detecting a fraud, whereas the logics and the rules were pretty simple to write, and still we took 2 years to just get to production, right? So that's has changed dramatically in the container world, because not just container, it also has something to do with people moving into cloud, right? So cloud is where you can actually, you have seen how the demo went when Miss Anvesha said, you go to cloud, you do this, you do that, you click a button, and you get your environment ready, and all is done. So development time and the deployment time increases if you use something like a container. And we talked about cloud native. So container by inheritance, or by default, it is cloud native, and that's why it is one of the most strongest container tool which is cloud native today. Okay, so this is one of the characteristics of containers. So you create them once, as I talked about that in the previous slide. So you will build a container once, you will push it to the registry, you'll keep it in the registry, and then you might use that forever. And I'll show that today in my demonstration, and probably I'll allow you guys to download my container in your local Windows box and run it again. So that's how it is going to be. If I am going to build an app today in this demo, you will be able to download that app and use it and run it at your own local environment. So you build it once, you share it, and anybody can run it. Containers are ephemeral. Now, the word ephemeral here means that it does not maintain a state. And that's going back to my the 1 or 2 slides back when I talk about state. Ephemeral is something which every cloud likes. So if you are not maintaining a state anywhere, cloud likes it. But without maintaining a state, you will not have the features which the modern applications provide. You may not have logging, and you're logging into a website, and if you maintain it ephemeral, it will log you out every 2 seconds, and you will not go back to that website again, right? So containers are ephemeral. So containers are meant to be ephemeral. That means once the container is destroyed, you do not get back the data from it. And containers will get destroyed once it is deployed. I'll talk about that later as well. Containers are pets. Containers are not pets, but cattle. That means, as I talked about pets and cattle in my previous slide, you cannot fall in love with a container. You have to kick a container out as and when you fit. And that's how you have to architect your entire architecture, that you have to accept the fact a container is a short-lived process, and it will go away and it will come back again. So it's a cattle, it's not a pet. Container limits access to resources. That means you can actually limit as much of the resource it needs. So this is a very good point in saying that there would be bad code. So people will write bad codes all over the place. And resource management is a very crucial aspect of managing, your workloads and deployments and whatever you're doing today, even your app. So if you limit the amount of resources your container needs, that's a big advantage which you have today. With that, what I'll do is I will jump into the demo. Before that, let me talk about what we're going to do in the demo. So this demo is structured in a way where you will see me deploying or building a container. I will talk about an image. An image is a source on which you build a container. And all of this, which I am doing today, is physically possible for you to do it in your home lab at any point of time. Even if it's not a lab, even if it's a laptop you can actually do this. Because as I said, containers are lightweight, very small things, and it can run just like any other applications you should have. And you have to understand everything, and some real life examples is everything Google does today, every application they have today is based on container. Maybe not their data part of it. The data part of it is still not moved into the container world, but every applications, you can say Gmail, you can say Google Drive, you can say even the Google search engine is actually based out of container. Anything Netflix does today is on container. Anything YouTube does today is on containers. So you running a container on your local laptop is a big step forward, because then you will know what and how to do with the container which you're running on the laptop, right? So we'll talk about base images, we'll talk about a runtime, and we will talk about the registries as well. So the next slide is registry. So first thing first, this is again, I'll talk and I'll come back to the slide again. So we'll go to this site called hub.docker.com, right? This is where you can actually register and create your own registry, but you don't need to do that. So this site gives you access to a lot of what we call base images created by the community, the open source community. And on top of the base image, you will develop your app. Now you can run your own registry. So on your once you start running your own container, you can actually run a registry, a version of the registry as a container itself, right? So you can run a registry on your local laptop. You don't have to always go to hub.docker.com. If you think that your data is too sensitive, and many organizations do this today. So if you have your own registry and it's secure, your images will have your own apps. You will not expose it to the rest of the world. You can actually do that. Registry is where you store your container images. You can build your own image, that is, you're building your app and storing it in a registry, and you can deploy it anytime. So let me quickly show you a few of the registry. So if you come to this site, you don't need to sign up. You can if you want, but if you can search any kind of software, you will get it. So one of the very famous softwares in the world is MySQL, is a database, right? And there's a container version of it. So if I say MySQL, it will give me a container image of MySQL. Now it says here, I have to do this to access this image, right? If I say Docker pool MySQL anywhere in the world, and if I have internet connection, I will be able to pull this. Now, only thing is I can only run this on a Unix or a Linux box which has Docker installed. So what I have done is I have a Google Cloud Platform account over here, and I will activate the Cloud Shell. Now, when you log into cloud, these are every day evolving and changing. This interface might look completely different tomorrow, but what they have done consistently across all three clouds is they have provided you a small shell, which is a virtual machine running in the cloud, and it is free of cost, right? So you can run any Unix or Linux level commands on top of it. So one of the commands we saw was Docker pull MySQL. So this is an image which is in hub.docker.com, and I'm going to consume this image, and I'm going to bring that, I'm going to download that image, right? What does this image give me? So here you can actually say MySQL is the most world popular open source database, right? So it has MySQL. So it's nothing but MySQL running on a container. So let me first see how we can bring this in. So I can just paste it over here. So Docker pool MySQL, and if I press enter, okay, so let me say, sorry, I might need to close my cloud session and do it again. Yep. So the Docker service was not running, so I just started the service. Now, when I typed in Docker pull MySQL, it will say that I am pulling from the library MySQL. So it's actually going out to hub.docker.com, and it is actually pulling out the MySQL image from here itself, right? So that's what it is. You'll find enough instructions over here in the page itself on how to start MySQL. And not only that, so very first instructions over here, if I zoom in here, you will see that it says, once you've downloaded this image, you can actually start it by this way. You can say Docker run, and then you can give it a root password. So the SQL database engine, you have to give a root password and then start it off, right? And you can also run it interactively and log into the database and create some database. However, I'm not going to do that. The intention of this was to show you that this is a registry where you have many images. MySQL is just one of them. You might find n number of images. In fact, as I spoke, I told that databases are not supported or not welcomed in the in the container world, but you will find everything here as well. So you will find even the databases. The reason why we do not say to run databases on the containers is because of the state problem. It is ephemeral, so it doesn't store data and it goes away. It's a cattle, so it can kill itself. All of that problem allows you to lose data, and that's the reason we do not say that it's still ready for supporting databases. But that's actually changing. So some of the NoSQL databases, one of them very common is MongoDB, you will be able to run that on containers today. So that's a registry. That's an internet available registry. You can pull images from here. First, check what images are available. To pull the image, all you have to do is run. They will actually provide you the detail over here. So it says Docker pull HTTPD, and you can actually pull it from running Linux system. So once that image is locally available, so I just ran and it's now locally available, I can say Docker images. It will show you MySQL latest. This is the version. And if I really want to run it, there's an instruction over here in this page as well, where I can actually say how to run that as well. So if I did MySQL over here, and there's an instruction over here which says how to bring this up. And that's how easy cloud is today. And that's how easy running a single container is today, right? Moving on to the next topic. So I'll go back to my presentation. Yeah, so you will be able to push your own images into the registry as well. And I will show you this. So let's go the next time. Okay, so we already used the command Docker, and I showed you what it is. So what is Docker? So Docker is a runtime. It is the management interface to manage containers. At the end of the day, technology has existed for a long time, but we as a community have not encouraged and used it as much as we should have. Back in the days, Solaris, which is another operating system, had a thing called Zone, which is again based on the same concept. However, that was not popular then. Suddenly, with Docker, when they came into picture and they started their company, it's actually an open source community, and then finally became a company. They popularized the concept of containers. I think it was last 4 years. 4 years from now, I think the things have changed a lot. We never had the courage to bring containers into production, which has happened very recently in big financial organizations. Some of the organizations like the big 3 IT giants, they have been using this for a long time, and they've confidently been using it. If you know, so Docker actually allowed you to build a management interface which allowed you to manage the container itself. But Docker is not the only thing, and they're also losing some ground at this moment. So because other open source community has come in, Google has invested a long, standing project. I'll talk about Kubernetes as well. So that's where container technology is evolving into. So we have other runtimes, which I think at the moment everybody is in a motion where they're moving away from Docker, but Docker is still the 90% of the management thing for all containers. So Docker, what it provides you is it provides you what I just showed you. So if you see my shell over here, this is the command which Docker provides you, right? And this command allows you to manage all your containers. That's the first thing Docker does. And then also it allows you to interact with the kernel namespace, container space directly, which was not there, right? So however, there are other runtimes like Containerd, Cryo, Rocket. All of these are new runtimes which allows you to do that. Most of the giants are actually going for that. That is because of how Docker maintained their code and how they released their code to the public. Other companies were not happy with it, and they're moving to other runtime. But the core concept of it is still the same. It is still kernel namespaces. It is still CNAME groups, C groups we call it, and it is the same concept. It's just how you manage that or how you connect to it is different. Today we connect it using Docker. Tomorrow we will be connecting it through a different thing. So if you have seen that I got an error when I started and it did not allow me, it said that cannot connect to Docker daemon at the Unix because Docker daemon was not running. So what I did, I quickly started that service, and then I was able to connect to it. So that's what it is. So it's a runtime. It needs a service to be running on the system where you're running it, and you will be able to see this in the process list. If I do a ps minus ef over here, you will be able to see, and this is a Unix command to get all the processes. And if I do grep docker here, you will be able to see that there's a process running with the docker PID, right? So this is a daemon which is running on my container system. Next thing is the container image. I talked about it. Now I will, no, I didn't talk about container images. So I did download an image from the internet. So this is a MySQL image which I downloaded. But what is an image? To put it very simply, an image is an image is a package. When you have built it, you have included your application on top of it, and you have included your binaries and dependencies with operating system dependencies as well. That's all an image is. So an image is the base or a source. When you run that image, it becomes a container. So sometimes people often get confused that, is my image a container? No, until your image is deployed, it is not a container. And one quick example I'm going to show here is, if I say Docker images, it has an image ID. And when I run a container I will run a container next, you will see that there's a container ID as well. So a container ID is unique and image ID is unique. Unique in a sense, image is a blueprint from which a container is created on the runtime, and the image can be reused anywhere. So the same MySQL image, if one of you is now sitting back home and saying, okay, I'm going to do what this gentleman is doing, I'm going to pull the same image. You will be running the same image ID as me. However, when I run the container, I will get a different container ID and you will get a different container ID. That's the difference. Image is a blueprint from which a container is created. Now you can create your own image, and that's the part which I'm going to show next, where I'm going to bring in a concept called building your images. Before that, let's see what the slide says here. So the image is a lightweight package of software binary which can be deployed on a runtime. Image consists of all the software that you or your app needs. You can build an image from a base image. So for example, what I pulled right now, so Docker pull MySQL is a base image, which is called MySQL, which has what software? It has MySQL in it, right? And you can add your own software on top of it if you want. So maybe you need a certain MySQL plugin for your database to work. Maybe you need a MySQL proxy inside it. Maybe you need something else inside it. You can actually do that in the image build process. Then you can push this image back to the registry, and you can use the same image in a different deployment. So that's what an image, the power of an image is. So that's why I said, if you refer back to my old slide, you will see that how I talked about that how can we package a software, where come this is where the portability part of it comes in containers. So you can package into an image, and then you can make it work in any environment, in any cloud environment, even in your local environment. And that's where it becomes a cloud native feature. The container image itself is a cloud native feature. Next thing we will do is we'll build an image. And now I'm going to talk about another thing. So for building an image, we need a file called the Docker file. Now, I'm not sure when we use a different runtime like Containerd or Cryo, they are also using the Docker file. So sometimes, if you are the pioneer, you leave some mark. So even if you are not using Docker in future, you'll keep using Docker file. So to build an image, you need a thing called Docker file. I'll show you what a standard Docker file looks like, right? And then inside the Docker file, you write certain instructions, and then that instructions is used while building the image. Then you do additional steps like installing your dependencies or your source code, which you have written, and you put it into a Docker file, and then your application image is created. So now what you have is a base image. If you add your application to it, you make it a container image, which is your application image, right? So let's quickly see this Docker file. So I probably have created a Docker file over here called Docker file, and it is case sensitive Docker file. So if you see, if I do an LL on it, so I can see a Docker file over here. So this file exists. Okay, let me open this file and see what is the content of this file. So I'll say vim Docker file. As I said, it has a from tag. A from tag means which base image am I using? And I had actually used a base image called HTTPD version 2.4. That's another thing I have to talk about on images as well. So let's look at this image in Docker Hub, because I'm pulling from Docker Hub. So I'm pulling the HTTPD image, right? And there is a thing called tags, and this is how you version your image. So the tags are nothing but version of your image, and you pull this and you version this image. So I'm actually pulling a specific version of HTTPD. Those who don't know, HTTPD is Apache server. Apache server is used to run your websites, right? So it's like your web server where you put your HTML code, your JS code, your CSS to run a simple website. If you want to run a complicated website, you can even do something like PHP, Perl, or Python. You can run it on Apache as a front end. So it's a purely a web server, and that's where we are going to deploy a small web page and see if it is running or not. So this is the tag, and if we go back to my demo here, so I'm pulling HTTPD and I'm pulling the version 2.4 from Docker Hub. So this probably is here somewhere. So 2.4 Alpine, I'm actually looking for this one. So if you see here, interesting thing, an image is made up of layers. So if every time I make and build an image, I create an additional layer. Other layers are read only to me. So when I'm pulling this image, so let me do one thing. Let me not directly build it. Let me pull this image locally and inspect this. So I can say Docker pull HTTPD 2.4. If I do this, I will actually pull, just like the way I pulled MySQL, I'm actually pulling HTTPD locally. Right now, what I will see is I'm pulling HTTPD image locally, and the same information, a validation that this is the same image or not, I can say Docker inspect, okay, and I can actually say HTTPD 2.4. If this doesn't work, what I will use is I will use the image ID. So if you see the layers over here, this has a CRC code here. What we call these are CRC codes, cyclic redundancy check code, where you actually see the hashing of that image. So if I go back to my Docker site over here, and you will see that the same hash will match as the layers, whatever I have downloaded. So that kind of verifies that your image is actually coming from a right source, right? So that's image. So now this image is locally available. So I can say Docker images. It will show me two images. One is MySQL one, which I've done before, downloaded before. Now I have the HTTPD one. Let's now go back to the Docker file and see how we can build our application here. So HTTPD, I'm pulling it from HTTPD 2.4. So if it doesn't find it locally, it will go and pull it from Docker Hub. What I'm doing next is I'm copying a file from my source system inside that particular image in this path. Okay, so people who are familiar with Unix operating system, this is a command we use to copy stuff. So we are copying a file called index.html from my local directory inside a directory called user local apache 2 htdocs, which is the image. It is not my local directory anymore. Now I'm copying it from the source, which is my server, the shell where I'm running it from, but I'm going to put it inside the HTTPD 2.4 image. I'm not putting it inside my directory. So how to see this? So I will use a command here to run this. It is called Docker build. So Docker build. So I'm going to do this Docker build, and then I'm going to say -t, And then I'm going to name this application. I'll call it My Apache. Let's change this name. Let's say My Website. Okay. Before even I do this, let me show you what's there in that index.html file. So if I open the index.html file, this is an HTML file. It has a page. Most of you might be familiar with HTML. It has a title. It has some links. It has an email tag as well. So this is a simple HTML file with a body and HR and paragraph and all that, right? So I'm going to copy this file inside my Docker image and build my application image, right? Build an application image from the base image. So let me do that. Docker build, and I'm going to change the name and I'm going to call it My Website. Okay, and then there's a dot. Dot refers where is my Docker file. So my Docker file is in this directory. So I'm building this image from this directory. So I'm going to do this and let's see what happens. Technically, what should happen, and I hope it happens in that order, it will pull that image if it doesn't find it locally. And then finally, what it will do, it will copy that file inside that and create a new image for me, right? And that's exactly what it happens. Step one was to download HTTPD 2.4, right? And you can verify this. Step one, the hash ID is CCBCA. And if you see when I have done Docker images, the HTTP ID is CCBCA. Next, what I have done is I've added the index.html file inside it, and it has become BCEF284B7B04. So the hash has changed. I cannot change the read-only layer of a Docker image. I have to add a new layer. Now this is going to be my image ID, or the hash of that image. So if I do a Docker images now, it will show me all the images which I have locally. So if you see, My Website is the new image which I have created. It is BCF284B708. So this is the new image it has created, right? So that's it. So I have written an HTML file. I have built my app. Now this app can be deployed anywhere in the world, in any cloud, and it should run in this exact same way, right? Let's now deploy this image and see if it works or not. To deploy, what we do is we use the Docker run command with some parameters. Now, in IT, we have learned that you must use -- help for everything. You don't have to remember all the commands. In your examination, you have to. That's the difference. So you can have the option to run -- help on all the Unix command, and you will be able to see this. So if you see there, I am doing Docker run DIT. D is in debug mode. I is for interactive. -- name. Then the running app, and then finally the name of the image I have built, and which is wrong here because the last time I did this, I called it My Apache 2, but this time the name of the image is My Website. So this is what I'm going to do, and what I'm doing here is I'm saying that, okay, when my Apache server comes up, I want to bind it to a port so that I can access it. Unfortunately, Google doesn't allow you to bind it on port 80, which is the default port for any website which you run. So I'm binding on port 8080, and you will be able to see this when I launch this website. So if I say enter, it will start. So something has happened here. Input output error. So I'll do a Docker. So it's very simple. I'll use Docker run -- IT -- name, and I think I've done something which is not correct. -p 80. Sometimes paste doesn't work in these. I think it's my connection which is the problem. Am I still audible for you guys? Because I did disconnect from Google. I might have disconnected from you guys as well. If I can get a confirmation from one of you that you can still hear me loud and clear.
Yeah,
You,
you are
we
audible.
are been able to hear you all throughout.
Okay, it's my network connection probably. Can you hear me clearly? Yeah.
Yeah, yeah.
Okay, cool. I lost connection and all of my data went away. So I have to do the build process again. So that this time I'm going to do the build again. And that's another thing. It could have been devastating for me to do this all again, but see how easy it is because I know the Docker file is still there in the server. All I have to do is a build. And once the build is done, I will be able to run this image again. So I've completed the build. Now I will quickly check what images do I have. So Docker images, and I'll see that my website image is available. And I'll then again do a Docker run here, Docker run, and I have to just change the name of the image. And that image has started. How do I confirm that image has started? So I can say Docker PS, which will show me all running images or all running containers. That was an image. I misspoke. This is now a container. This is no longer an image. It has used my images blueprint and created a container with the container ID you can see. How do I verify this? I've just deployed my website. I've probably created a blog. How do I check this out? So I can check this out on a web preview over here, and I can preview on port 8080, and it would show me my website. So I've created this website. I could have 10 pages. I could have added 10 pages, but I've just added one page, which is index.html. I can add pictures to it. I can add anything to it, and it becomes a HTML website for me. So that's how easy it was for me to deploy an image on top of on running an image on a Linux system. One thing I need to do is now I can actually stop this, and it will. So I can say Docker stop, and then I can give the container ID over here. So if you see the difference, the image ID and the container ID, they're not same. Often in the industry, there's a confusion between the image and the container. They are not same. Image is a blueprint from which a container is created. And once the container goes away, when it comes back with a new container ID. I can actually kill this one. I can say Docker RM, and I can say the container ID over here. I'm removing this container. I can actually use force over here. So I can say Docker RM -F, and it will automatically remove that container. And if I again run the Docker run command and bring up my new website, this time it will have a different container ID. So if I say Docker PS now, it has completely different container ID. So that's what you have to understand. The image ID will remain consistent once the image is built. Docker container ID will change as and when you keep on deploying the same stuff all over. That concludes the demonstration of containers. You can see how powerful containers are. To build an app, all you need to do is install Docker, and you can do this on your Windows laptop, on your Linux laptop, or anywhere you can actually run an operating system. Any computer where you can run an operating system, you can do this, and you can build your own app, package it, and then push it. What I didn't show you guys was the pushing part, the fun part. Now, I will have to log into my sign in. I have to show you what images I have built. So you can log into Docker. You can log into Docker anytime. Create a sign up ID and log in. Okay, I might have forgotten it, but yeah, I'll skip this part of the demo because what I was going to show you is there's a command called Docker push, and I will be able to push the image I have created. And that for that, I would need an ID in Docker, and I have to authenticate, and I will push my image, the new image which I've just created. I will be able to push it back to Docker Hub. That means any of you can download it, the website I've just built, and deploy it anywhere in the cloud. That's how simple and easy it is. The reason I'm skipping this is because I've forgotten my Docker Hub password. I have to reset it. And that's why I'm skipping this. But that's a very simple process. So all I had to do was Docker push, and I had to push the image which I have created, not the container, the image which I have created, which is my website. And it would automatically ask me for ID and password, and it will push that image. And then what you have to do is probably search that image, my website in Docker Hub, and then finally get it for download it. So what I can show you is there is me who has created plenty of images in Docker Hub. So there you go. So that's how you will find me with that name, KAMBUI. So these are all my images. So these are all sample images which you can actually download and deploy. So there's a Ruby application, there's an IBM MQITP, there's a Call Me application, there's a Node.js application. All of them are available for you to download and deploy it anywhere you want, on your local laptop or on the cloud. Okay, so with that, the demonstration part of this is done. Next thing I'm going to do is go back to the slides, and there's a couple of more slides to talk on. Now you saw how we ran a single container. Kubernetes is taking that to a next level where you're actually deploying and orchestrating this containers deployment, right? This is a server client level architecture where you have masters which will control how many containers needs to be deployed, where it needs to be deployed, which machine it needs to be deployed on. If there is a problem with that machine, I'm going to stop that and start in somewhere else. All of these are the functionality of Kubernetes. Now, to talk about Kubernetes, it would take another 4 hours. So just get into the thing of Kubernetes is the next hot cake in the industry in terms of managing an orchestration layer for containers. But the basic principle of containers remains the same. It's namespace, kernel namespace, C group, where you're actually virtualizing the kernel itself so that you can isolate a particular application or service inside it. And the orchestration layer, which is Kubernetes, which is again developed by Google, what it does, it orchestrates multiple containers in multiple worker nodes, multiple machines, it has a lot of features like scheduling. That means you can schedule a container based on memory usage, CPU usage, and all that. You can also scale up and scale down based on your requirement. Let's say your website is getting 1,000 hits per second, you can scale up and you can scale down anytime as well. Okay, so that's Kubernetes. Kubernetes is a whole new topic altogether, but just to learn Kubernetes, you have to start with containers and you have to start developing app on containers. Then comes to the part where you will orchestrate that container deployment into a multi-cluster mode or in a master and worker node model. Next steps for, I think, most of us and all of us is to go, what is the next step is learning about these things are pretty easy these days. It wasn't as easy in a few years back. I would highly recommend you guys to go to these website, which is SRE, which is Site Reliability Engineering Practices. Now, this is derived from Cloud Native. SRE is a systems engineer or a network engineer and more than that. So SRE is a modern system engineer and modern network engineer. Today, every system engineer, every network engineer, or aspiring system engineers and network engineer have to be skilled in SRE. So it has to be, they have to know how to code. They have to know all the 3 cloud platforms. They need to know how to do automation. It's not just about building physical servers and switching on and powering on and cabling them. That has changed. Nobody has access to these anymore. You will have to build your servers using code. You have to maintain your servers using code, and you'll have to write that code all by yourself. So SRE is that practice, which is a Google initiated practice, and every organization is adopting this practice, which is SRE practices. Cloud Native Computing Foundation, the people who manages things like Kubernetes and the open source container engines. We talked about Docker. Docker is still managed by Docker. It's been recently bought by Mirantis, but Cloud Native Computing Foundation is an open source organization which maintains these standards, and they maintain Kubernetes. Initially it was developed by Google, handed over to CNCF. CNCF maintains Kubernetes, the source code of it, also the new release, the new version of it. They also maintain the newer version of the container engine, which is replacing Docker, which is CRI-O, container runtime interface, which is CRI-O. And then finally, they're also maintaining some native tooling on top of the container platform, which is much more ahead of time than today's discussion. So that's where it is. Now, one thing I would like every one of you to do, and I think this is pretty easy to do, this is the link where you can actually download Docker for Windows desktop. There's also a link in that same page for Linux. In Linux, it's pretty easy because it's cloud native, and Linux was the base platform where containers was developed. So it's very easy based on the Linux platform you are in. If you are already, if you are working on Linux day to day today, or if your home computer is Linux, you will probably have figured out how to install Docker by now. But on Windows, this is the link where you download it from. You install it, and then whatever I did today, you do it from a Windows command prompt. So the Docker command, whatever I run, you do it from a Windows command prompt, and you will be able to simulate whatever I've done today with a good internet connection, because Docker Hub is still in internet, and you have to get the images from internet. There's another website, which is cataconda.com. If you want to learn more about Kubernetes, this is a nice website, which is a free website where you can actually see videos and you can actually learn about Kubernetes as well. With that, that's the end of my presentation. I might have overshot the time. Yep. So back to you guys. If you have any questions.
Thank you so much, sir.
Thank you, sir. One question. Sir, one question from Siddharth Chatterjee.
Yep.
Sir, please tell me something about multi-tenancy in cloud with real life example. And last line he writes, if your time permits, then only.
Sure, no worries. I think multi-tenancy is that's again a cloud feature which is by default into cloud. And when I can actually show this to you guys. I'm still presenting at the moment. So if you see, when I go into my cloud, this is Google Cloud. This only shows me a dashboard with my project. So what cloud does is cloud creates a name, just like a namespace in the container world. Cloud creates a project in your name. If this is an enterprise organization, they will create a project in the enterprise's name, and then you will be able to manage all that within your project. So this is the tenancy or multi-tenant concept in cloud, and this is where I think your resources, your compute resources, your database resources, whatever you create in cloud today is only visible to you and you only. And people question this because from a very physical level, and it's a very good question, from a very physical level, even I question this, that is it really that my stuff can be seen by me only, or some other tenants or some other cloud consumer is able to access my content, which is actually true, that they are not able to access my content at all. And that's what multi-tenancy in cloud is all about. Now, if you ask me whether it is absolutely sure and the security of it, they all reside on the same physical host. Even if Google or Amazon or Azure, they don't tell you, they might be in the same data center, and we can't do anything about it. Right? So they are in the same data center. My project, and if you create a project right now, will be probably, may not be, in the same data center. But still, because of the software defined controls they have put in place, the cloud application they have built, we have to trust that, yes, I am not going to see your data and you will not be able to see my data.
Thank you, sir, for your valuable and informative speech.
Thank you.
Dr. Bhattacharya, I have just one question, if time permits, of course. You
Yeah.
said that containers are basically cattle. Now, what makes them cattle? Because is it the data that gets exploded, or is it the functionality has to change? Although you said that a particular container does a very it accomplishes a very basic functionality,
Yep.
but still it has to change. Why is it so?
Yeah, so that's again a cloud native concept, being a create cattles and not pets. When I say a container is a cattle, there in one of my slide I talk about the ephemeral nature of a container. Whatever you write inside a container, not the image but the container itself. So when the container is running, if you are writing a log file or if you are writing something in a file, once you kill the container or remove the container, that thing goes away. And the whole architecture of containers have been made to make sure that you accept that fact that the container will run in one machine today and it will be moved to another machine the next day. And who will decide this? The orchestration tool. Because the orchestration tool will see server A has memory available, server B is in a memory crunch. There are 20 containers running in server B. I have to move the containers from server A to B. I will kill all the containers in server B and move them to server A. The orchestration tool today, I did not touch upon much on the orchestration tool because that's a big topic. That's the cloud native orchestration tool which I'm talking about, which is Kubernetes, right? And a container must be designed, your application must be designed in such a way that it is a cattle but not a pet. That means anytime I will be expecting an outage, not an outage in the sense my service will go down, but outage for that container will get killed and redeployed in another server or another machine. So that's the concept of comparing a container as a cattle, not a pet.
So this particular process, is it
Yeah.
tackled? Is it accounted for by the orchestration without
Yes.
The person who has actually initiated the container, that person's intervention?
Yes, this is completely controlled and automated by the orchestration tool itself. So that is why when you're writing your app, you have to write your app in that way. You have to develop your software in that way. You have to accept the fact that it is not always going to run in the same machine. It's not always going to run in the same data center. It might not run in the same cloud. So I have to write it in such a way, in such generic fashion, in such variabilized and parameterized fashion, so that I am not dependent on the hosting platform where it is running. And that's being cloud native.
Okay, so at the point of initiation of that cattle, that means initial it's not cattle, the container, the design part, if I am conscious about it, then orchestration will, the remaining part of it's having to be moved to another location, that will be taken care of by the orchestration part.
Absolutely, you're spot on. Absolutely.
Okay. Thank you.
Thank you, sir. Any more queries? Okay. Thank you, Opik sir. We have really a very wonderful session, and the way you have demonstrated and showed us how to deploy it, it makes the session very interesting. Thank you so much, sir.
Yeah, thank you very much for giving me this opportunity, guys. Thank you very much.
Thank you, sir. Thank you.
Thank you very much.
Okay, sir. Okay, now moving on to the next part of the session. Now I would like to request Lipi ma'am to continue the hands-on session. Lipi ma'am, please.
Thank you, Sudipta. Now we will move forward to our next presentation. I would like to take the opportunity to introduce our next speakers of the day. We have two speakers together for today's hands-on session, Mr. Balaram Ghoshal and Mr. Ashim Kumar Panda. First, I am introducing Mr. Balaram Ghoshal. Mr. Balaram Ghoshal received his Bachelor of Technology in Computer Science and Engineering from West Bengal University of Technology in 2005 and Master of Technology from Bengal Engineering and Science University. He has over 12 years experience in academics. He is currently working as an assistant professor in the Department of Information Technology, BP Poddar Institute of Management and Technology, Kolkata. His research interest includes visual light communication, operating system, and IoT. Our other speaker, Mr. Ashim Kumar Panda, received the Bachelor of Technology in Information Technology from University of Kolkata in 2008 and Master of Technology from University of Calcutta in 2011. He is currently working as an assistant professor in the Department of Information Technology, BP Poddar Institute of Management and Technology, Kolkata. He has more than 8 years of teaching experience. His research interest includes visual light communication and IoT. Now I would like to call upon Mr. Balaram Ghoshal and Ashim Kumar Panda to join us and share the screen. Thank you. Hello.
Hello. Hello. Anyone response, please? Am I audible?
Hello.
Yes.
Yes,
Am I
yes.
audible to everyone?
Yes, yes.
Okay. Thank you. Then. Well. So, is my screen visible to you? Is any presentation visible to you? Oh well. I'm presenting. Yeah. Well, I think it's visible right now. One and all, before we begin demonstration of the IoT module, let us have a quick recap of what we learned so far in IoT. Well, these are the things we will move through. Firstly, what actually IoT is, then why the need of IoT to our existing world, how it happens exactly, and finally, there will be few case studies with the demonstration with ESP8266, a Node MCU module. Fine. So what is IoT? As this topic is already discussed in previous day, I'm directly fetching the definition as per wiki. The Internet of Things is a system of interrelated computing devices, mechanical and digital machines provide with unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. So it's a system which does not need human interaction directly to this system. Well, now at the beginning, let's have a look at this very popular smart device connected anywhere. Okay, we all know these smart devices. Yes, they are the smart speakers, right? The first one is a product of Amazon Incorporated. The name is Alexa. The second one is called Siri, and this is a product of Apple, followed by Google Now by Google and Cortana by Microsoft Corporation. Now, all the companies claim their device as a smart assistant. They can play music as we want. They provide information about things. They can set an alarm. They can even book our movie ticket from bookmyshow.com. And what not, all those jobs they do automatically in a while. So that's why they are called smart device. Well, after knowing what IoT is, let us enjoy one video. Yeah, just watch this video. It's a video by Telenor Corporation. It's available in YouTube as well. Please watch it first.
The Internet of Things, or IoT, is expanding in nearly every industry. In this film, we will look at the benefit of connected products and IoT, and why more and more leading companies and businesses start connecting their products. The main drivers are often to reduce costs, improve operational efficiency, and increase overall customer experience. One of the most important reasons is that companies can reduce costs. With a connected product, troubleshooting can be done remotely, which cuts both labor costs and solves issues quicker. There is also a big cost savings by being able to prevent outages and failures with remote monitoring, indicating where risk is high. But connected products can also help companies to improve operational efficiency. By condition-based monitoring, service can be carried out in the right time and only when needed. Connected products means access to end-user data, which can lead to increased customer experience. Companies can now develop products on real user insights and offer new add-on value services. Another important benefit is that companies can offer faster and more effective customer service based on user data.
Well, so why IoT? From the video, we can sum up these points. Now, a number of sensors are connected to an IoT system, and the sensors are collecting data continuously. So, in any smart system, there is a lot of data available to analyze. Naturally, better decision can be taken. The second one is the ability to track and monitor things. As various different sensors are connected to the system, all information is coming to the IoT controller to track things. Next, the overall system gets automation as it does not require human to computer interaction. For example, when we enter into a smart home, the lights on automatically. The fan also starts moving without our intervention. On the other side, when we leave the room, light turns off automatically and the fan stops moving. As a result, saving the electricity. This example also gives a peace of mind to the house owner, both physically and in comfort. As a result, it gives a better quality of life. Okay, now moving from a single smart device to a smart cars. Okay, a smart car is a composite collection of different smart devices. As you can see, through a DSRC, that is a dedicated short-range communication module. All actually different sensors are connected from the car, which is further connected to a mobile wireless gateway. Now, the mobile wireless gateway is connected to the user tablet or phone and an external antenna. The mobile device or the smartphone is then further moves to the through the cellular network to a data center available in some internet service. And the external antenna connects some Wi-Fi network and the GPS satellite to get its live location. And there is also a user interface inside the car, is as in the dashboard, which gives the user a comfort, a safety, and all from the car. Well, so in this way, a simple car becomes a smart automated car. Okay, here you can see different sensors connected to a car. Actually, there are many more sensors are connected in a car. Here we display only those things. Now, by the way, a sensor is in its broadest definition a device, module, machine or subsystem whose purpose is to detect events or changes in its environment and send the information to the electronics, frequently a computer processor. In case of a car, it is the DSRC. So, yeah, few of the sensor connected to the car, as you can see, the first one is a fuel level sensor. Actually, this is a sensor present inside the fuel tank to meter the gauge of fuel present inside the fuel tank and accordingly sends signal to the DSRC and to the MCU for processing, and the MCU process that how much distance the car can move and when it is a requirement to refuel again. The next one is a wheel speed sensor. This one is a sensor which continuously monitors the speed of wheel. Based on the wheel speed, the safety precautions and the safety measurement is taken inside the car by the MCU. The third one, as you can see, it's a mirror sensor. Actually, inside the mirror, rear view mirror, there is a sensor which senses the light condition, the object present background to the car, and the weather condition. It changes automatically, controlled by the MCU unit. And then you can see a transmission sensor, a range sensor. Well, a headlight range sensor is a sensor which controls the headlight, whether it will be a deeper or wider, what will be the color for the light in different weather condition, whether it is fog or in a rainy situation. All is preset in the MCU. After sensing by this headlight range sensor, the MCU sends proper sensor signal to the car operator and the car automates in light. And there are many more sensors like a motion sensor, the combo sensor, steering torque sensor, the steering sensor, all sensors and many more are connected to the car, right? Now, using all these sensors, the car gets a full automation both in safety and to the user. Fine. Now, have a look in some more smart devices, rather gadgets. Many of us already have smartwatch or fitness tracker in our hand, in our wrist actually, which can measure our step count, total walking distance, our pulse rate, and saturation of oxygen in our blood, and whatnot. Then we have a smart lock. Actually, smart lock is a part of home automation which controls the entry and exit of a authorized person to a smart home. And the last one is most popular nowadays in this lockdown situation, in this COVID-19 situation. It becomes very an essential product to us, a smart TV. By these, what we can do, we can watch live channels, we can listen to radio, we can see the live news, we can check live weather, and we can see even live content, web content from the websites. Presently, our smart television become a smart mode of communication through video chat, through the inbuilt webcam and audio sensor, right? Well, so now moving to the point how IoT works. Let's have a look in another example of IoT in home automation. Well, here you will see a full application of IoT in the home automation. Here we have a Raspberry Pi 3 as an IoT module. Actually, this one is a single board computer with wireless LAN and Bluetooth connectivity to control connected device at home. Few sensors are connected to Raspberry Pi 3 module to receive senses input, and few appliances like light, fan, ACs are connected to be controlled by the user through the internet, through their mobile application, and some automatic instruction available as preset. Well, now if you move closer to the light sensor, yeah, inside this light sensor you can see a photodiode present. Well, this photodiode senses, this photodiode with in composition with of light in a room, and then the signal is passed through this signal pin, and there are the VCC pin and GND, the ground pin, is also present to get the power for this light sensor. Well, we have another sensor over here, is a PIR sensor. Okay, PIR sensor stands for passive infrared sensor, which actually use as a motion sensor or a motion detector. Now, if you see inside this bulb, there is a infrared light and a infrared reflector. Fine. So for a specific range in a room, the infrared light moves on to a particular range, and then if something happens, if some object moves, if someone move inside the room, the reflection in the reflected changes, and accordingly it sends the signal using this three pin, the VCC, out, and ground pin, and this happens continuously. Fine. The next one we have a temperature sensor. Well, this is a sensor as per the name, it senses the temperature. Actually, inside this box, it has some kind of thermistor, and that thermistor continuously monitor the temperature change, and in a frequency of few seconds, it sends the signal using this three pin. Okay, so if we move back, here you can see in this home automation application, in a IoT system, generally there are four layers. in the IoT architecture. Okay, have a look on it. Yeah, the first one, as you can see, is called the sensing layer, where all the sensors are present and they are connected to the IoT device. Fine. In the sensing layer, we have some GPS sensor, we have light sensor, we have heartbeat sensor, we have audio sensor, and so on. Now, the sensor from the sensing layer through some network layer, through some gateway, connects the processing unit present inside the IoT board, right? Now, the IoT board contains some processing unit as well as some graphics processing unit, a GPU, right? Now, after processing, the processing unit sends signals both to the appliances at home, in our example, and to the user for their convenience to know the information, to know the status about the or about the all the appliances. Now, in the network layer, you can see different network can be used: the Bluetooth network, the Wi-Fi network, the mobile network itself, and some WiMAX network. Actually, there are different network which can be used in this network layer to form the entire IoT architecture. Well, now here is a list of some basic sensor and ready-made module compatible with Node MCU or Arduino IoT kit. Now, what is Arduino? Arduino is an electronic platform based on various hardware and software. Both Node MCU and Arduino boards are able to read inputs, say light on a sensor, a finger on a button, or a Twitter message, and turn it into an output like activating a motor, turning on a LED, publishing something online, etc. However, there are some functional difference between the Node MCU and the Arduino Uno kit. We will focus on, actually in our live session, we will focus on Node MCU, which is somehow better to the Arduino board. In our following session, we will live various applications using Node MCU. Before move forward, well, here you can see in the right hand side in this table, I have many sensors connected, sensors available, which are compatible with both Node MCU and the Arduino, right? Now, this left hand side are some sensors and the right hand sides are some module. Actually, the module are used to generally produce some output or to detect some senses in the sensor, right? Now, if you see this particular module, a high voltage relay module, this particular module is used with a IoT device or IoT system to control the high voltage appliances in our home or anywhere, right? And if you see the sensors, all the sensors you can see are self-explanatory. Like a heartbeat or pulse sensor, it is generally present inside our smartwatch to detect our pulse. A knock sensor is for sensing the knock inside some metal or inside in some object. Now, some vibration sensor to detect the vibration, water level sensor to detect level of water. Generally, this water level sensor is used frequently in home automation in the overhead tank to automate the motor and to automate to minimize the use of electricity to control the motor. And we have metal touch sensor, obstacle detection sensor, photoresistor light sensor, as I mentioned in the PIR module, temperature sensor, and ultrasonic distance sensor. Now, the main thing in this sensor is all the sensor is very much less expensive, around 10 to 15, up to maximum 50 rupees. You will have 100 of sensors. Fine. Okay, so before moving to the difference between the Node MCU and Arduino, let's have a look in a short video. Hope you will enjoy this video. Well, hope you enjoyed this video. Yeah, actually, this is a video clip from the movie Mission Mangal. All you know, right? So what we found from this sort of video, number one, implementing home science can be done anywhere, including Mars mission. And number two, cost minimization is must to deal with things. Anywhere we have to do this cost minimization. Looking on here, moving forward to the Node MCU. Well, moving to the Node MCU, this is a teeny IoT kit with a bunch of very good functionality. This kit is developed by Espressif Corporation. As a result, the device technical name starts with ESP. In our live demo, we'll deal you with the ESP8266 module. Now, why Node MCU? The most attractive feature of Node MCU is its inbuilt, ready-to-go Wi-Fi chip. This is a complete microcontrolled unit, a MCU, with full TCP/IP stack. That is, TCP/IP protocol in computer networking is preset over here. Moreover, this is a low-cost product in a very little size. Even you can hold it in your thumb only, in your palm only, I'm sorry. The first generation of Node MCU came in August 2014 in technical name ESP01. Fine. So the Expressive Corporation comes only in 2014, 13-14, and it arises so that it's only because of its low-cost IoT kit and the inbuilt Wi-Fi module. Let's have a closer look in this IoT module. Okay. Yeah. As you can see on the board, the Wi-Fi chip is inbuilt over here, right? And there is some SRAM. Actually, a RAM is embedded over here, and there is some flash memory, one processor, and there are pins with 16 general purpose input output pins. Okay, and there is a flash button to flash the memory and a reset button to reset the entire system. Well, so yeah, here we have a comparison among the Arduino Uno kit and ESP8266 kit. Actually, we are keeping aside the Raspberry Pi module, as Raspberry Pi module is much more costlier than these two, Arduino Uno and ESP8266. And the Raspberry Pi is something different. Actually, that one is the kind of mini computer on board. So we are just comparing between this Arduino Uno and the Node MCU ESP8266. As you can see, the bold, as I have mentioned in bold, they are some advantage over the other. Now, if you consider the cost, the Arduino Uno cost around rupees 3,000. And if you see ESP8266, which is readily available in Amazon or Flipkart, the price ranges 400 to 900 only. Now, if you see the inbuilt, flash memory inside the Arduino Uno, it is only 32 KB, which is 4 MB in case of ESP8266. Now, if you consider the SRAM, it is only 2 KB in Arduino Uno, and in ESP8266 it is 50 KB. Now, if you see the clock speed, well, they are almost same. In Arduino Uno, it is in a band of 20 megahertz, and in case of ESP8266, it is 24 to 52 megahertz. Well,
classmarker.com এটাতে অনলাইন এক্সাম নেওয়ার কথা ওরা স্কুল থেকে ভাবছে
if you consider the GPIO pins, the Arduino Uno, in Arduino Uno, the number of GPIO pin is only 14, which is 17 in case of ESP8266. And another important thing, all the 17 pin in ESP8266 are pulse width modulation enabled. So modulation based function also can be done using any of the pin in ESP8266, which is only 6 in case of Arduino Uno. Whatever, the Arduino Uno wins in only one thing, that is number of analog to digital converter present inside it, which is 6 in case of Arduino, and in ESP8266 it is only 1. The operating voltage for both is same, almost same. It is 5 volt for Arduino and 3.3 volt for ESP8266. And finally, the most important thing, that's why we choose the ESP8266 as our IoT module, is its inbuilt Wi-Fi, which has to be installed separately in Arduino Uno. Well, so here is the detailed pin diagram of Node MCU, which will be very helpful to our next demos. You can see all the GPIO pins. GPIO stands for general purpose input output pin, the VCC, the ground, the signal, the VIN, and to connect the sensor, there are many more pins available. Well, so we will just in this demonstration following me will describe this ESP8266 physically. Now, here is a mapping of the Node MCU ESP8266 and Arduino Uno. Actually, we will write our programs in the Arduino IDE, and there we have to mention the Arduino Uno pattern, which is present inside this left side. And the same pin is mapped to these pins, like D0 is mapped to GPIO 16. Well, so when we will do, when in our next session, when we will write program using Arduino IDE, we have to follow the mapping scheme between the ESP8266 and Arduino Uno. Well, this is okay, let's begin with the live session. Fine, I have taken the videos and images from this website. I'm sharing this with you in few minutes. Over to Asim Kumar Panda. Thank you all. Over to Asim. Hello, anybody there?
Hello, am I audible?
Over to Asim. Thank you, Asim.
Yes. So, thank you, Balaramda, for the nice introductory part for the hands-on session. So, right now I will want to thank to all the participants for the time actually. So, we are running a little bit late. So without any more detailed introduction, I think I will go to the hands-on activity live. So at first, what I will do, I will show you one live IoT device that will help you to understand what we want to display on what we want to. So I think right now all of you can view the circuit board. And okay, in this board we have one node MCU, and with the node MCU board we have some sensors actually. So right now I will focus on my camera on the sensor right now, and this is a IR sensor, and this is the node MCU board. Right now with the board we have one relay associated with the board, and this is a normal LED bulb that is available with the board. So okay, so right now what I will do, I will just put my finger, okay, and just watch the event. So the light is on, okay, and after 10 seconds the light is off. Again I will put my finger before the sensor. Again the light is on, and again it will turn on mode for 10 seconds. And yeah, we can customize it. Obviously we can customize it. If you don't put the delay or the time duration, automatically it will be off after on event. Okay, so this is the activity we will demonstrate here, because right now we are in a hurry because lots of time is already there. So let's have a quick discussion on how to develop this kit and how to develop this circuit actually. So right now I will share my presentation. Okay, I think the PPT is visible to all of you.
Yeah, it's visible.
Okay, so let's move to the next slide. So this is a small video. I think you will have interest on this video also. So just a few seconds. I will not take too much time for this video. Just a few seconds. Okay, and then I will start my next slide. So watch the video. Okay, then I will move to my next slide. Okay, again another video.
Alexa, TV on.
Okay.
Alexa, it's hot.
Okay.
Alexa, turn lights on.
Okay.
Alexa, dining room off.
Okay.
Alexa, turn on channel 9.
Okay.
Alexa, it's cold. Alexa, it's cold.
Okay.
Alexa, turn TV volume down.
Okay.
Alexa, good night.
Okay.
Alexa, play songs by Biffy Clyro.
Play the songs by Biffy Clyro from Spotify.
Alexa, next song. Alexa, turn it down. Alexa, stop.
So this is an example of Alexa home automation. And okay, so actually we will organize the entire hands-on session in two parts actually. In part one, we will give you the introduction of Node MCU, then the sensors. After that, we will set up the Arduino IDE because that is a vital part of our IoT application development. And after that, we will execute the Arduino code in Arduino IDE. So today we will cover the part one contents, and tomorrow and day after tomorrow we will move to the part two. So as Balaramda already discussed this IR sensor, so right now what I will do, I will show you one physical sensor that is available with me, and I have developed the application with the help of this IR sensor, okay, for this IoT device. So right now in the IR sensor that I have with me, so 3 pins are available with the IR sensor, okay, one for output. That output pin will be connected to the Node MCU board. One is source, voltage source, and it is 3 volt, and or 5 volt depending on the sensor that is available. And there is another pin that is ground pin, okay, and 2 LED are available with the sensor, one for transmitting, another for receiving, okay. So this LED will transmit the infrared. So this is the sensor we will connect with our Node MCU board for this type of device development. So right now I think I will move to the sensor. So I will show you the sensor right now that is available with me. Yes, I think the sensor is visible to all of you. Okay.
Yes,
So
it
two
is
sensors
visible.
are there basically. The first one is one LDS sensor. Later I will describe it. And so right now I will focus on the IR sensor. So this is the IR sensor I have, and all of you can see that 3 pins are available here. So I want to focus it more on the pin configuration. So 3 pins are available, one for out, and for the obviously for connecting the Node MCU board, another one ground that we will connect to the ground pin of Node MCU, and the third one is DCC on voltage source. And you can see both the LEDs, both are available. So what we will do, we will connect this IR sensor with our Node MCU. So I will move on to the board. Actually, this is the circuit configuration right now I have. So this is the Node MCU board. I think all of you can recognize it. And this is the IR sensor. I have installed on the breadboard. So these are the 3 pins. Those are connected with the IR sensor. Okay, so these pins are connected to the node MCU, and okay, so I will focus it on the circuit configuration actually. So this is the actually ground pin. Actually, I have a common ground for all the configuration. Okay, and from that pin, the IR sensor ground pin is connected. And I think a little bit hazy is there. Actually, lots of wires are there in the configuration. So better the theoretical part or the PPT slide will give you more detailed view on how to connect the IR sensor with the node MCU board. Okay, so and okay, one interesting device is there that is obviously most valuable in case you want to develop an IoT enabled device, that is the relay. Okay, so this is a relay switch. So first I will describe the relay switch. After that I will move to the physical demonstration. Okay, so again I will show you another sensor, that is a IR sensor. That is the LDS sensor. So this is the IR sensor and this is the LDS sensor. Okay, so in this sensor also we have 3 pin available with the sensor. Okay, one for A0 or analog pin, another one is ground and VCC. Okay, so here you can notice that one pin is D0. Okay, and this is the actually data pin. So through this pin the LDS sensor will transmit the value, okay, to the node MCU. So and again there is another sensor, that is the DHT11 sensor. Okay, so right now I will show you the DHT11 sensor also. I think all the sensors are properly visible.
Yes, it is visible, Asim sir.
Okay, fine. Now in the DHT11 sensor, the DHT11 sensor is available in the middle position. Okay, now in this sensor also we have 3 pin. Okay, and one is plus for VCC, the next one is out or the middle pin, and the third one is minus or ground. So we will use these three sensors with our node MCU board to develop applications, not only applications, to develop IoT enabled applications. Okay, so right now what I will do, I will go to my presentation again to describe some of the parameters. Those are essential for the development of the IoT device. So this is the IR sensor. I have already described it. Okay, so 3 pins are there: VCC, output pin, and the ground pin. So the circuit configuration is very much easy. You don't have to do too much complex wiring actually. VCC pin, obviously just connect the VCC pin with the 3-volt pin of node MCU. Next, go to the output pin. Now that we have to configure in Arduino IDE. That is what pin we want to use. So there are lots of pins available in node MCU, like D1, D0 to D7. Okay, so you can choose anyone. Depending on your customization, you can choose anyone. Okay, and that pin you have to connect with the output pin of, then it's enough. And third one is ground pin. So just you have to connect the ground pin with the node MCU ground pin, and that's it. That is the entire circuit configuration you have to do. Okay, very much simple and easy, and I think anybody can do this circuit configuration. Okay, and okay, before going to the application, actually how the idea came to my mind regarding this device. Actually I have this device at my washroom. Okay, so basically at my home there is a problem. What is the problem? Actually most of the time I forgot to switch off the light at night. So now you can imagine that what will be the situation. So at morning I have to switch it off. Now for the entire duration the light is on, and all of you know that what is the cost of electricity unit. So that is the big reason. That's why I have developed this device actually, and it's for my own purpose, because I want to minimize the energy bill, and at the same time I want to save earth. Why earth? Because obviously I can minimize the CO2 emission if I will use less unit. Okay, so that is the cause actually. I don't know if this is the case in most of the household, but in my case that is the big problem. Okay, so that's why I want to automate my LED bulb that is available at my washroom, so that after a specific time period, automatically it will be off, and when I will enter my washroom, automatically it will be on. So I don't have to switch it on or off. Okay, and rest of the things I think Node MCU and cloud and IoT will manage. Okay, that means we can customize it. Okay, so actually in Balaram in his slide that told you that why IoT. So obviously in industry there are lots of not lots of thousands or millions of reasons to go for IoT, but for me I think our day-to-day life requirements are more reason. That means more give you more energy that to focus on the IoT enabled device, because we need this kind of device to automate our day-to-day life applications. Okay, so next we will move to the next slide. Okay, so this is the IR sensor and this is the node MCU board. Actually, this is the circuit configuration. So here I have connected the VCC with the 3-volt pin, and after that the ground pin with the ground, and then the output pin is connected to the D7. Okay, so the D7 pin of node MCU is connected with the IR sensor output pin. Okay, and one simple LED is connected with the node MCU board, and that is connected, the positive point is connected with the D6 pin, and the ground is connected with the negative of LED. Okay, so this is the actually circuit configuration that I am following for building this device, and it is, I think, very much easy, and anybody can do this circuit configuration. So not at all complex, and we don't have to put too much activity on building the circuit configuration. Okay, so this is the LDR sensor. I have already described it, so I will move to the next. Okay, this is another circuit configuration with LDR sensor, and this is small speaker actually associated with the node MCU board. So automatically, whenever the light will be low or high, depending on your requirements, okay, the speaker will speak. Okay, that means there will be sound from the speaker. Okay, so, and it is also very much simple and easy, and just you have to follow the pin diagram, and for this we don't have to do too much complex wiring also. So these are the very simple applications we can develop at our home without too much complexity, which are without too much efforts. Okay, so this is a circuit diagram actually of a smart street light. So we can have a smart street light depending on IR sensor, LDR sensor. That means what right now I think it is common in our country also. In Kolkata we have this during evening automatically the street lights are on, and at the morning the lights are off. So those are basically controlled by this kind of sensors, and you can say smart devices or smart valves. Okay, so right now we can have this kind of devices at our home and in our society also. And this, obviously there is a reason behind this, because this will save our energy and manpower also. So we don't have to turn the street light manually on or off. Okay, automatically whenever the condition will be satisfied, automatically the light will be on or off. So it will do a great job to our society also. Okay, next topic is relay switch. So this is a good component actually, I will say. Why I am saying good? Because without this we can't control the 240 volt we can't control the devices. Those will run on 240 volt source. Okay, so how to use this relay switch? Okay, and okay, this is the example. This is an example of 2 relay module. Actually 2 relay modules are available in this switch. That means using this module we can connect two LED bulb, or maybe not LED bulb, we can connect a fan or anything, any device we can connect, okay, that will run on 240 volt. Okay, so these are two relay module. Currently I have 4 relay modules so that I can control 4 devices. Okay, now this is the pin configuration we have with the relay switch actually, and this is the sockets we have with the relay switch. So we'll move to the next slide. Yeah, so we have one common socket. Okay, so the mid one is the common socket, and actually we will connect the 240 volt 240 volt connection with this pin, okay, with this socket. So this is the socket for 240 volt main connection. Next we will have NC pin, okay, or normally closed pin, and later I will discuss what is NC. Before that I will go to the next pin, that is normally open. So in relay switch we have 3 sockets available for the electrical connection. The first one common socket, the next one normally closed or NC, and the third one is normally open. So in case of normally closed, by default the circuit will be closed. That means by default the bulb will be in on mode, okay, it will be on. And in case of open, bulb will be off unless you say